Hello interwebs, welcome to Let's Fix Computers. We're looking at a Dell Latitude E series today with no power. So we've got it plugged into the mains with no battery and it's stone dead. The customer tells me that they have already replaced the DC in jack on this laptop, so theoretically this should not be as simple as that. However, we always take the customer's advice with a pinch of salt. So the first thing we're going to do is strip the laptop down and see what we can find on the visual inspection. So with the multimeter in voltage mode, we're going to start probing the pins of the power jack where it meets the motherboard. So we're going to go one pin on ground and one onto the live pin and start checking if there's any output there. And it looks like there's nothing, so this might be as simple as a bad DC jack after all. I've just pushed it out of the connector and I'm probing the pin directly, and the multimeter is giving me nothing at all, it's just millivolts on the screen. So let's take it apart and do a closer inspection just to see if it turns out that the customer just replaced the DC jack with another bad DC jack. Okay, so we've got the DC jack out of the laptop, and now when we plug in the charger we're actually getting voltage out of it. So it's not a bad DC jack after all. So next let's plug it back into the motherboard and see what's going on there and see if we can replicate the problem we had earlier on. And sure enough, now we're connected up to the motherboard, everything is getting dragged down again. We're barely getting 1 volt out of it. So there is a short circuit in this laptop that is dragging the main DC in to ground. So let's start hunting for that. The first thing I'm going to do is put my multimeter into resistance mode, and we're going to check the resistance across the main DC jack. So this is not always helpful, but it's sometimes an indicator of what's going on. We have 70 kilo ohms here. On a healthy laptop, I expect to see 80 to 200 kilo ohms. So 70 is on the low side, but it's not a dead short. So let's start peeling back some of this plastic film and see if we can take some pot shots at where the problem might be. So I've switched over to continuity mode or beep mode on my multimeter, and I'm just going to check for beeps across any large looking components. And already I can see that we are getting beeps on these 2 capacitors that are near the DC in jack. So these are going to be smoothing caps for the DC input. So this immediately confirms that we do have a short to ground. So we need to start figuring out what these caps are doing or if they're the culprits. Just because they're reading shorted to ground doesn't mean they are the culprits themselves, because it could be something else and our continuity is going around the caps through the short. So we need to try and map out the path that we're taking from the DC jack to those capacitors to see what else might be in the way. However, at this point, we're going to either need to roll the dice or we're going to need to find a schematic. And I've opted to locate a schematic, so a bit of Google searching later and we are no longer flying blind. So here is the DC in jack section of the schematic. We've got the DC in jack on the left, then we've got some, it's labelled Dell feature peak power, which is obviously some kind of cut-off mechanism for safety that can switch off the power brick if there's a problem, which is most likely what we're experiencing here. And then on the right-hand block section, we've then got sort of the outputs to the rest of the circuit through that big MOSFET on the right, which is PQ4. However, there's nothing here that really looks suspicious to me. There's no real load-bearing sections that I can see could be shorted to ground. There is a token gesture grounding capacitor in the left-hand block in the EMI section right in the middle there is a capacitor there. But yeah, that's not really load bearing. This is just filtering stuff. None of it really looks like it's liable to fail. So this is not going to be it. So what we're going to do is trace through this section and make sure that that all goes where we expect it to. Now, if you've watched my previous repair videos, you may remember that I've seen a Dell laptop that had basically the same issue as this, where the charger was cutting out or otherwise not powering the laptop. And I actually have a very strong suspicion that we're dealing with exactly the same fault here. So I'm going straight into the battery charger section. So I followed along to the battery charger section of the schematic, and as you can see, we have a very familiar layout here, where there is a battery charger control chip, which is then connected to a buck converter and also a current sensing circuit with a crap ton of grounding capacitors, of decoupling capacitors scattered about. And these decoupling capacitors, like the ones that are circled in red on the right hand side there, this is the kind of place where I expect to see failure points, where there is a loss of power being decoupled from the circuit to ground. That is where we're likely to find dead caps. So we need to start checking all of these guys out. Now, I can check if I'm actually in the right ballpark with my theory here or not by removing the current sensing resistor that is the big square in the top right of the screen right now. Now, if I remove that current sensing resistor, it's going to disconnect most of the battery charger circuit from the rest of the laptop. Now, if I find that the short appears on the output side of that resistor, I'll know that the short circuit is indeed in the battery circuit and the battery charger. Whereas if I remove that resistor and find that the short circuit is on the left hand side at like pin 1, that tells me that the short circuit was actually somewhere else in the laptop. So this is a very quick way of checking if my theory, if I'm actually onto something or not. So let's get that off the board. So now we're going to put in the multimeter again, and we're going to check each of the pads where that resistor has come off to see which ones are shorted to ground. So we should find that the inputs are not shorted, but the outputs are shorted. And sure enough, we're seeing that the output pads are beeping in continuity mode. Alright, so we're getting somewhere. Now, if we move along to the right-hand side of the current sensing resistor, we don't have a lot of more branches this time. And in a way that's good, because it means there's less stuff we have to check, but in a way it's bad because there's no real things that I can take off to isolate here. We're getting to the point where I just need to start taking components off until the short disappears. Now, the next thing along, we've got a large inductor, which is PL400, and then there are two capacitors there decoupling to ground. Those two guys are extremely tempting. They're on top of the board, they're the two capacitors that are right next to where I've been looking, and considering that I've still got the motherboard in the laptop, it's extremely tempting to just go in and rip them off of the board. So that's exactly what I'm going to do. But sad trombone, we're still shorted to ground. So touching continuity on both sides of those pads, there's still a short circuit there despite the fact that the caps are gone. So this is not it, we're in the wrong place. So at this point, we've basically done everything that we can do on the top side of the board. So I'm going to take the motherboard out of the laptop so I can take a look on the bottom side. Now we're on the other side of the board, it's a little less clear as to where exactly our power stuff is. So I'm just going into continuity mode and I'm just going to start beeping around at random just to see what I can find. This area next to the battery connector seems quite likely, and I've got more shorted capacitors here. So it looks like I've found the next region of the battery charger circuit. So what we need to do now is compare this on the schematic so we can figure out exactly where I've got up to and which components are likely to be our failure points. So we're now down in the section where that red ring is in the bottom right. We've got another bank of decoupling capacitors, but I can't see all of these on the bottom of the board, but there are a couple of largest looking ones. And the next section of the circuit is the MOSFET for the buck converter, and I doubt that's going to be our problem. So we're going to start pulling off capacitors again until we lose our short. This is a very brute force approach to finding the problem, but without having any actual board diagram to tell me where the circuits all are, this is probably the fastest way of solving the issue. So let's see how far we get. And sure enough, our short circuit has disappeared. We've got ground on one side of these pads, on the right I believe it was, and then on the other side we do not have ground, so the short circuit is gone. And just to be absolutely certain, I'm going to flip the board back over and check the input sides of the battery charger, which we were previously seeing were all shorted down. And likewise, those caps that we previously took off the board, they're no longer shorted to ground either. Ground on one side, no ground on the other. So what about the caps themselves? Well, in resistance mode, we can see, as I very much fumble about with them, that this guy is charging up when we stick the probes across it. However, this guy is reading a dead short straight away, no hesitation. So now we've got the dead one and the live one, and we can put the live one back on the board again. And now another quick resistance test, and we find that we have a charging resistance starting from about 2 or 3 kilo ohms building up across that capacitor. So it's now behaving exactly how it should do. So now I've dropped the motherboard back into the laptop and we're ready to give it a quick test run just to check if we've gotten anywhere. And as soon as we plug in the charger, we've now got a white power light over on the right hand side, and after a few moments the laptop actually fires up. And so now we know that we've actually solved the issue, we can go ahead and fully reassemble the laptop. And that's it, we're all done. So the laptop is now fully functional. We can't check if it's charging a battery or not because the customer didn't supply the battery. However, I did warn them about this, and I told them if it doesn't charge the battery, bring the laptop back. So they did not return, so presumably the battery is also charging. However, we've now seen that this seems to be a known issue with Dell laptops, certainly at least from this era, where these decoupling capacitors in the battery charger circuit are prone to failure and will prevent the laptop from being able to run on mains power. So watch out for that in the future. Thank you very much for watching, everyone. I will see you all next time. Goodbye for now.